Hey everybody. So just like I said, wanted to make another video just kind of talking with you about the calculations for heat energy and specifically using specific heat of water to make those calculations. So what you can see here is our equation for heat energy, our heat equation. Okay, E stands for energy. We're specifically talking about heat energy. Sometimes we use a Q here as well. Mass needs to be in kilograms. Specific heat will be in joules per kilogram degree Celsius, and the change in temperature is T2 minus T1. That's change in temperature. In other words, this little delta T that I have over here, that would be the change in temperature, triangle T. That's T2 minus T1. That's your final temperature minus your initial temperature you're starting. Okay. Now remember this equation, what we're doing is we're looking at how much actual energy is gained. So if we have two pots of water, one that is, they're both boiling, one has 1 kilogram of water and the other has 2 kilograms of water. More water, same temperature, means that one has more energy, right? It's going to take longer to boil. It has more energy. So this equation is what we would use to calculate how much energy that is. Okay, the question that I have listed here says a coffee maker heats 2 kilograms of water from 15 degrees Celsius to 100 degrees Celsius. It's boiling. How much thermal energy was required to do that? Okay, so I set up my guess method. I currently have things covered up so that we can kind of go through them one at a time and you can kind of see what we're doing here. Okay. I added this triangle up here. I'm only going to have you calculate for energy, but if you have a question that calculates for mass specifically or delta T, mass would be energy divided by Cp times delta T. Cp, so remember, just use that triangle. We divide, if there's something on top and bottom, we divide. Across, we multiply. So energy is equal to mass times specific heat times change in temperature. Okay, but mass is equal to energy divided by specific heat times change in temperature. Okay, so that's how we use that triangle. In my class, you guys have seen that. You guys know what I'm talking about with that. So now back to this question. We have a coffee maker, that much water. One thing that we need to know here is that the specific heat of water, 4,184 joules per kilogram degree Celsius. I need to change that. I'm going to change that right now. Per kilogram the degree Celsius. So right here, I can actually do this. I'm going to take this little O that I made and change it into a degree sign. Sorry for doing that on the computer and not having it done beforehand. Anyway, here we go. I'm going to show first my given information for this question. Right here, my mass is equal to 2 kilograms. Temperature, my T2 is equal to 100. T1 is equal to 15 degrees Celsius. And then the specific heat of water, right? What I am looking for is how much thermal energy. So my unknown is energy. In my equation then, using the equation that's up there, mass, specific heat, T2 minus T1. And all I need to do then is plug in my numbers. Kilograms times joules, or times my specific heat, times that change in temperature. If I put everything in right, everything works right. Okay, comes out to 711,280 joules. I think there's one question on your review questions that has you actually do these calculations, and I know that you'll have to do it on your test as well. Not a lot of practice, but you have your equation. You also have that in your reference materials. Not a bad idea to put this equation in your notes. It was in the PowerPoint as well. It was in the textbook, so you can take that equation and put it right in your notes. That's what I would recommend, guys. Okay. Now another question, same concept, same idea. We're heating up water. I have 30 kilograms of water, so I have more water now, and I'm taking that from 15 degrees Celsius to 50 degrees Celsius because you know what? I don't have any heat in my house, and I need to warm up water for a bath. It's going to take a lot of energy, isn't it? So here we go. Get rid of that box to look at our given information, 30 kilograms. T2 is 50, T1 is 15, and my specific heat of water. Looking for energy, and I use my specific heat equation. Well, then I just need to add in my numbers, set it up, and solve it. I did not solve this one. I figured that you guys would be able to do that. Go ahead and practice it. Type it into your calculator, 30 times 4,184, and then in parentheses times 50 minus 15, so times 35. Okay. So just a couple quick questions to help you with those specific heat calculations, because like I said, there are some questions in your review that make you answer that, and there will be on your Chapter 9 test. Thanks, guys.